In this video, I will explain example number 4.6 of chapter number 4, which is our assignment problem, question number 25. Let's get into the 4.6. Now, first we will understand the code. Then we will run it in Proteus. This program basically reads a state of push button connected to pin B2 of the microcontroller. Depending on the button state and the program outputs either the character Y or N or on port D. Let's check the this the CBI DTRB2. Here we are basically controlling the direction of port B, either 0 input or either 1 input. Here button will be connected, so we set the DTRB pin as port as input. Now port D here is 0x5. This means that all the outputs of the port D is set as output. Now we have port D as an output. This is an assembly language code. So again, here is a main loop. In main loop, the microcontroller will continue to run this point and keep checking the button state. In PB, SBIS means skip if bit in IO register is set. So if PB2 is equals to 1, the instruction is skipped. If PB2 is equals to 0, the instruction will be executed. Then again, jump instruction to over, which if PB equals to 0, the program jumps to the label over, or if PB2 is equals to the jump instruction, it skips the program, executes Y. So at register 16. Now loop again, here it is over. In over section, here the program leads the SSI2 value of N into the register 16. Look here. After the program jumps back to again to continue checking the button, the button press. So the overall program behavior is basically button release, PB2 is equals to 1, then output will be Y. Button pressed, PB2 is equals to 0, output N. Now let's run it on Proteus. Now here we will start a new project. Let's set this 4.6 example. Next. Next. Now here create a firmware project. Here we will select AVR, then AVR at mega. We will require to do it at mega 328p. This one, as it is assembly language, then we will select this. Next. Yes, I think we don't have copied the code. We now run this. The program is compiled successfully. Now to test, we will simply adjust some settings. We can add virtual display as it is in SSI 1, but we have to set many things like but, speed and else. So instead of doing that, we will just add LEDs and check them in binary. Now select something, LEDs, red. Let's select this. Again, push button, and now let's at pin B2 we have to attach a button, which is I think pin 14. Yes, and a ground. Now here we can select a ground. So let's add 8 LEDs. 3, 4, 5, 6, 7 and 8 LEDs. Now let's have some connections at pin 0. As all the outputs of the D we have set it to outputs. Sorry for the wait. Now let's connect the ground. Let's simply add another ground. Simple connections. Our code is of SSC2, but we will convert it in binary. Now I'll tell you how. Wait just a second. Now first I tell you what is. As we know, we need Y. In SSC, Y is equals to 0 x in basically in decimal. 0x 59, 59, which is equals to in binary uh, 0 1 0 double 1 double 0 1. Yes, let's set it to 0.8 inches. 8 inches. Okay, now another. Let's select n is equals to in decimal in hexa it is 4e, 4e, which is equals to in binary 0 1 double 0 triple 1 0. This is in binary 0 1 double 0 triple 1 0. Okay, now just adjust it. The program was compiled already, so let's now check this. At we said that when the button is released, so we had output y. Program is not actually basically the program behavior was that at when the button is released, pb2 is equals to y, output must be y, and when pb2 is equals to 0, output n, when the button is pressed. Now check it. Look here, it is 1 1 double 0 double 0 double 1 double 1 0 1 0. Okay, now when the button is pressed, check the behavior. 0 triple 1 double 0 1 0. This shows that the or code is working accurately and perfectly. Just check shifting. When the button is pressed, it must be show n. When button is released, it show y. So thank you for watching.